Hello everyone, welcome to my video on exploring geospatial data with WebGIS. I am Nirita, currently a 4th year undergraduate student pursuing Bachelor of Geomatics Engineering at Kathmandu University. So today I will be walking you through an interactive map which I created as my project using Leaflet, GeoJSON and various APIs. From mapping administrative boundaries to real-time weather data, earthquake visualization and various amenities that are present on our localities, this project truly showcases the potential of using geospatial technologies. So I'll be sharing my screen with you, and let's dive into the project. Sharing my screen with you. Before moving on to the coding part, I'd like to give you a quick preview of my final map with the features and layers enabled, how the map looks like. So in the screen we can see the final map that I have made using HTML, CSS and JS. The title is entitled as WebGIS Exploring Geospatial Data, where I have explored various data like province, administrative boundaries, which includes province, new districts, palikas, that means the municipalities, other various live real data featuring earthquakes, amenities around our localities, weather data. So whenever you click on some part of the map, you can see the information about the weather. So here we can see weather, clear sky, temperature, humidity, and likewise we can when we click on these markers, we can see the details about the earthquake that happened on that place, where we can see location, magnitude, date, etc. Likewise, we also have location file of 58 students of our class with name, district, municipality and province. So this was the quick preview of the final map. So now let's move on from the beginning, where it all started. And the first part was data collection and preparation. The foundation of this project was geospatial data collected in a structured format, including names, municipality, district, province, latitude and longitude of 58 students of my class. Converted this data into GeoJSON, ensuring compatibility with mapping tools like Leaflet. So to convert this data, I used mapzipper.org, where I imported the CSV file and converted it into GeoJSON format. The validation of the GeoJSON file was done using GeoJSON lint to avoid errors. So the second part was adding the base map. I used Leaflet to integrate OpenStreetMap as the base map. This provided a detailed and user-friendly canvas to build upon. The tile layer function allowed dynamic fetching of map tiles for smooth zooming and panning. Let's move on to our coding part. Here we have this code. First we have displaying title and author name on the topmost part of my map. So by enabling input type as checkbox, we can enable or disable weather data display on the map. A div with ID map is where the interactive map is displayed. The CSS ensures the full dimension 600 px, height and full width. So this part creates a leaflet map centered on the given latitude and longitude with a zoom level of 7. Moving on, adding a base layer, the L tile layer adds OpenStreetMap tiles as the base layer with attribution. The group of features, example province, district, earthquake, are stored in L.layer group objects for easier management and toggling. This part of administrative boundaries, each GeoJSON file, for example palika.geojson, represents a specific administrative boundary. Likewise, new district and province also represents specific administrative boundaries. This part here fetches data from the GeoJSON files, applies styling and adds them to the respective layers. Let's have a look at the map for this part. So when we turn on this layer, we can see the province, 7 province of Nepal. Likewise, we also have the districts and palika, which are shown in the map. Next, I brought the map to life by integrating real-time data using APIs, earthquake data from USGS API, visualize seismic events with circle markers scaled by magnitude. Weather data from OpenWeatherMap allowed users to click on the map and retrieve real-time weather information for any location. So moving on to the course, this whole code is earthquake as circle markers where size reflects magnitude. The pop-up shows details of location, magnitude, and depth. Now moving on to the weather data handling part, on MapClip, the function fetchWeather retrieves weather details from OpenWeatherMap API. The pop-up shows display weather details like temperature, humidity, and description on the click location. Likewise, this cons URL part queries amenities, example restaurant, hospitals, banks, ATM, drinking water, and all the facilities available on that location when the location is clicked using OpenStreetMap's Overpass API. So let's have a look at the map again. We tick on the amenities, and the weather data is on weather, and the weather data feature is already enabled. Whenever we click on some places, it shows the weather data. Likewise, it also shows amenity around here. Likewise, in this place we have Saraswati Sidan Mabi nearby. Likewise, we also have another amenities, place of worship, which is unnamed. And likewise, when we turn on the layer for earthquake, we can see the circle markers. Whenever we click on the circle, it shows a pop-up with location, magnitude, and date. Moving on to our next part, I personalized the map by adding my classmate's location using GeoJSON, complete with interactive pop-ups. Additionally, I performed a school proximity analysis to highlight school within an 8-kilometer radius, visualized with a centroid and circular overlay. The location.geojson is loaded and displayed as marker with pop-ups, including name, district, municipality, and province. Likewise, this part loads school data and performs a proximity analysis, calculates the centroid by averaging latitude and longitudes, draws an 8-kilometer radius circle around the centroid to visualize the proximity analysis. We can also see them on the final map whenever we click on the schools here. By zooming onto this location, we can go for the school is unnamed. We have Sri Bal Vidya Mandir Secondary School, which is my location. When we click on the location file, this is my location, and whenever we click on the proximity analysis, this is the circle of radius which was created using the code. So likewise, to enhance usability, I added labels, custom icons, and a layer control panel, which is shown here. This allows users to toggle layers based on their interest. Moving on to our coding part, at last we have this layer control.layers code, which allows toggling visibility of various layers that I used on my map. So this project taught me the power of geospatial tools in visualizing and analyzing data. From integrating APIs to styling layers, it was an exciting journey of combining technical skills with creativity. Last, talking about the overall features, the features that are included in the map are administrative boundaries, earthquake data, weather information, amenities, school and proximity analysis, which provides an interactive and layered approach to exploring geospatial data. This was all about my project demonstration. Thank you for watching, and I hope this inspires you to explore geospatial data visualization. And if you have any queries, you can also visit my article which is posted on my LinkedIn, and you can add me on my LinkedIn. My username is Nirutani Upane. So thank you very much.